Hi everybody, welcome to 9.5 Systems of Inequalities. So the last lecture dealt with just inequalities themselves, and now we're going to look at multiple inequalities within one graph. Okay, so the solution set of a system of inequalities is the intersection of the solution sets of the individual inequalities. So if you remember last time, we talked about shading. Right? So with a system of inequalities, the solution set is where the shading overlaps. Okay, so the overlap, the shading that represents a solution for both inequalities. Okay, so we're just really going to focus on two of these examples. If you'd like to try B and C on your own, I will post the worked out solutions so you can check them. All right, but we're just going to focus on example A and D for now. All right, so let's go ahead and move on to this first example. All right, hopefully we recognize that x plus 2y is greater than 4 and 2x minus 3y less than or equal to 12 are both linear inequalities. So if we're going to graph this first one here, all right, since we are in standard form, we can just come up with our ordered pairs. Our intercepts. So when x is 0, we get y to be 2. And when y is 0, we get x to be 4. All right, so one thing we need to remember is the dashed or solid boundary line. Okay, so in this case, since it's strictly greater than, we're going to be dashed. Okay, so we have the point 0, 2 and the point 4, 0. And we're going to graph a dashed line through these. Okay. Now, I'm just going to test a point again to determine where I'm going to shade. I'm not quite going to shade yet. So because the point 0, 0 is not on our boundary, I can test that point. Okay, so when I do test, I get 0 plus 2 times 0. So I get 0 is greater than 4, right, which is false. So we're going to shade above this line. So I'm just going to make a note right now, because if we start shading, things can get kind of ugly, okay, and confusing. So now let's go ahead and graph this second inequality. Okay, again, it's in standard form, so all we need to do is graph the x and y intercepts, plot those guys, and then draw our line. So when x is 2, we get y to be negative 4. When x is 0, we get y to be negative 4. When y is 0, we get x to be 6. Okay, so we can plot those points. Now, because we're strictly less than or equal to, we're going to be a solid boundary this time. So I'll plot the point 6, 0, and we'll plot the point 0, negative 4, drawing our solid line through these points. Will look something like that. I'm going to test another point. Again, I can still test 0, 0, since that's not on my boundary. Okay, so when I plug 0 in for x and y here, right, we get 0 is less than or equal to 12, which is true. So I'm going to shade in that direction. Okay, so now what we want to look at is where is the overlap going to occur? And what I can see is that both of the solutions point to this region. Okay, so this is the region where my solution set is, and that's where I'm going to go ahead and shade, and that's where our solution to this system occurs. Any ordered pair within that shaded region is the solution set of this system of inequalities. Okay. All right, so that takes care of our first example. Let's move to example D here. All right, so this might be good practice looking at our first inequality. We have ourselves a line, all right, in slope-intercept form, right? So what is our y-intercept? Well, we should know that that's the point 0.07, and our slope is 2. So we should be able to plot this relatively easily, all right? I'll plot a few points using my slope and my starting point of 0.07. And since it's strictly less than or equal to, we're going to have a solid line here. Okay, so 0.7, use my slope of 2, so count up 2 over 1. And I can go down 2 and to the left 1. Okay, and we said we have a solid boundary. So we've got that looking like so. I can go ahead and test my point here. 0, 0 is not on my line, so I can test that nicely. When I do test that, when y is 0 and x is 0, I get 0 is less than or equal to 7, which is true. So that means I'm going to be shading to the right of this line. I'm not going to shade yet. I'll shade at the end. Okay? All right. What we should recognize about this second inequality is we have ourselves a quadratic. Okay, remember it's a parabola, so it either opens up or opens down. So who remembers how we find the vertex? Okay, so our vertex, remember we can find the x value of our vertex, which is equal to the opposite of b over 2 times a. So in this case, if we are in the form y equals ax squared plus bx plus c, you notice we don't have a b value here, okay? So when we're trying to find the vertex here, I'm going to go back up. Okay, our b value is 0. So we have 0 over 2 times 1, which is just 0. So our x value of the vertex is 0, and when we plug that in to find our y value, we get y to be 1. So our vertex is the point 0, 1, and I'll put this all in a table, okay? So I'll make our table of values. I'm going to put our vertex smack dab in the middle. I'll choose a couple points that surround it. So we have 0, 1, that's our vertex. And remember, quadratics are symmetric, so we can choose some points that surround it. So I'll just choose x values 1, 2, negative 1, negative 2. And when we plug these into our inequality up above, when x is 1, we get y to be 2. When x is negative 1, we still get y to be 2. When x is 2, we get y to be 5. And same for when x is negative 2. So we can plot these points, okay? One thing to keep in mind, though, is we have y is strictly greater than x squared plus 1. So we have a dashed parabola that we're going to be drawing, okay? So we have the point 0, 1. We have the point 1, 2. And negative 1, 2. And we have the point negative 2, 5. And positive 2, 5. All right, and then when we graph this or draw in, it's going to be a dashed boundary. Now, I might want to make sure I extend my parabola to intersect that other boundary, if you can see that okay. All right, so now we need to test a region. Okay, so I can still test the point 0, 0 since it's not on my parabola curve. Okay, so if we test 0, 0, what do we get? Well, let's see, we get 0 is greater than 1, right? Which is false. So since that point is outside of the parabola and it's false, that means for our parabola, we would be shading on the inside of it, okay? So I kind of make that note here. All right, so where is the overlap going to occur? Well, what we should notice is, again, we're shading to the right of our line, but we have to shade inside of our parabola. So we're going to be stuck in this region right here. And so now we can go ahead and shade, and the solution to this system is going to come on the inside there. Okay, one thing I need to note is don't always assume where the solution set occurs. Make sure you check a point and verify that it is or is not true where you're looking. Okay? All right, that's all for today. Bye.